This tutorial is going to be on nomenclature of ionic compounds. Nomenclature is just a fancy word for the naming systems. Now, when you have an ionic compound, you're going to have a metal and a nonmetal. Now, you can see on the periodic table that it's mostly made out of metals. We have our metals here, our transition metals here, our inner transition metals, and then we have our other metals and metalloids. Our nonmetals are located right on this side of the periodic table. Now, for nomenclature, you will need a periodic table. The first thing that we should do is label it by our charges. Now, the naming system goes hand in hand with your ionic compounds, with your metals and nonmetals. Now, our first group will have a +1. Our second group will have a +2. Skip a few in the middle, and then we go to a +3. Now, carbon's a tricky group. Some will have a plus or -4, and then we start with our negatives. So we're going to have -3, -2, -1, and no charge at all. Now, with our transition metals, they can range between a +1 to a +6. Now, with our transition metals, we'll look at it in a little bit on how that affects its nomenclature. The same applies to the bottom inner transition metals. Now, when we're looking at our ionic compounds, we're looking at a metal and nonmetal coming together. Now, when we name a metal just by itself, it will be whatever the name of the element is plus ion. So if we have K being potassium, if it's K plus, it's going to be a potassium ion. Now, if we have O just by itself, it's oxygen. If it's O -2, it's going to change its ending to IDE. So instead of oxygen, it's now going to be oxide. So let's try a few examples. We have Na +1. How did I get the +1? I'm going to come back to my periodic table, find Na, go up, and take a look at its charge. Is a +1. So to name it, we're going to say sodium ion. Now, Mg is a metal too. We're going to locate it, and it has a +2 charge. So we're going to go Mg +2, and it's going to be magnesium ion. So it's not too tricky when we're looking at our metals. Now, our nonmetals, we have Cl. So we're going to find Cl on the right of our periodic table. We're going to go up, and it has a -1 charge. So we have Cl -1. So we're going to change chlorine to chloride. So this INE ending now becomes an IDE. So we have a chloride ion. So let's find Br. Br's here. We go up to a -1, and we're going to have, instead of bromine, we'll have a bromide ion. Now, nomenclature is the naming system. So we're going to start combining our metals and nonmetals to make an ionic compound. Now, the charges become important because we're going to learn the crossover method. So let's find Na again on our periodic table. We found Na, it has a +1, so I'm going to put it right next to it here. And Cl, all the way on our right, has a -1 charge, which we already can notice is that we're going to have a 1-to-1 ratio between our two charges. Now, we're just going to name this for right now. So we have our metal. Do we do anything fancy with its name? Nope, it stays the same. We're just going to eliminate the ion because it's just not a sodium ion. So we're going to have sodium here, and then chlorine becomes our ide. So it's sodium chloride, and that is our first ionic compound with nomenclature. Now, I mentioned the crossover method. Now, the crossover method is what we'll use to actually get the formula for sodium chloride. Now, with the crossover method, you do not cross over the signs. The only thing you do is the number. So the 1 would go this way and the 1 would go this way. Since it's a 1-to-1 ratio, we're going to have sodium chloride's formula be NaCl. Now, if they turn out to be like a 2-to-2, 4-to-4, you still have that 1-to-1 ratio. Now let's try another example. So let's find magnesium on our periodic table. So we find magnesium, it has a +2. So I'm going to write a +2 right here, and let's look for Br. So let's find Br here, and it has a -1 charge. Now it's not a 1-to-1 ratio, so cross over the number to get the formula. So we're going to have a 2 here, and we're going to have a 1 here. Now it's tacky to show the 1. You can if you'd like, but I suggest that you do not show it. So we have an MgBr, and then we just have the 2. So for every 1 magnesium, we need 2 bromides. Now let's name it. So magnesium stays the same, and bromine now becomes bromide. So this compound, according to its nomenclature, is going to be magnesium bromide. Now we have Ca. Go back to our periodic table. Ca is here, so it's going to have a +2 charge. And F is also in that halogen group where our Cl and Br were, so it's going to be a -1. So let's cross it over. The 2 goes to the F, the 1 goes to the Ca, and we have CaF2. Let's name it. So Ca is just going to be calcium, and fluorine is now going to become fluoride. A big mistake when naming fluorine is that you want to put the O before the U. Not in this case, U before the O. So let's look at our periodic table. We have K as a +1, so we'll put it right next to it. And then we'll have our S as a -2. Now notice how these are all superscripts going to subscripts. So charges are super, meaning on the top. How many there takes, or after the crossover method, is a subscript. So 1 goes to the S, 2 goes to the K, and then we're going to have K2S. So K's name is potassium, and we're going to have sulfur become sulfide. So this formula is potassium sulfide. Now when we get to transition metals, since they have numerous different charges, you'll have to show your charges by Roman numerals. So you'll see that you'll have, for a +1 charge, a Roman numeral 1 right behind it. So it could be like copper parentheses 1, +2, 2 I's, +3, 1, 2, 3, and +4, you'll do the 1 and then the V for it, and so forth. Now if we look at Cu +2, this 2 lets us know the Roman numeral. The symbol lets us know what metal we have. So we're going to have copper 2 here, and then followed by whatever anion we have. Now we have Co +3, so we're going to have cobalt, and this 3 tells us what goes in the parentheses. So we're going to have 1, 2, and 3. So we'll have cobalt 3. Now let's combine it with some anions. So we still have that copper 2, so this 2 tells us the charge here. But this 2 also helps us with the crossover method. So we're going to have copper 2, fluorine, we look at the periodic table, is going to have a -1, so we'll put that behind it. So fluorine becomes fluoride, and the formula is going to have the 2 go to the F, the 1 go to the Cu, so it would be CuF2, meaning that for every 1 Cu, there are 2 fluorines. Now, exception to the rule. three elements will always have the same charge. We call it the backwards L. Right at zinc, cadmium, and silver, they will always have the same charge. Zinc and cadmium both being a +2 and silver always having a +1. You will not show Roman numerals for this backwards L on your periodic table. What I suggest to my students is color this in as a +2 and then color this in a different color. Hopefully this helps with nomenclature of ionic compounds. Thanks for watching.